So we need to go through and solve some system of equations here, and I'm going to use the Gauss-Jordan elimination. The Gaussian elimination is you just stop sooner. The Gauss-Jordan, you take it a few steps further, and I think it's a little bit easier, in the long run. But let me back up and let's revisit some algebra for a system of equations from back in like a high school algebra 2 type setting, okay, or a college algebra class. There are several ways that you can solve it, and one of those, and my favorite, is just to use the elimination method, right? And what you do is you take an equation and you try to eliminate one of the variables by adding one equation to the other. So what we got to do is we got to match things up and go, okay, let's say I want to get rid of x1, okay? I want the coefficients to match. So I'm going to multiply this one by 2. And if I do that, I get a new system of equations. The first equation stays just like it is. Okay? And then the second one would be a negative 2x1 plus 8x2 equals 0. Okay? And then I look and go, aha! The coefficients for the x1 match up, and I know if I add those two equations, I get a 0x1. I've eliminated the x1, and that's the important part here. Okay, because 2 plus the negative 2, and then we get 11x2 equals 0. And that gives me this nice simple equation, the 11x2 equals 0, so x2 must be equal to 0. And then I can go back and substitute into either one of the original equations for the x2 and find out what x1 is supposed to be. So I'm going to use the second equation. Okay? So I'll use this one right here. Okay? So negative x1 plus 4 times 0 equals 0. And then the negative x1 will also equal 0. So my solution, okay, would be x1 is equal to 0 and x2 is equal to 0 in this case. Okay? That's how we would tackle this problem back in a college algebra type class. Okay, now I want you to look at the steps and think about this, because now I'm going to do this one with the Gauss-Jordan elimination. Okay, and I want you to compare the steps. Keep in mind what we're doing here is we are writing these equations as a matrix. Okay, so that's going to be 2, 3, 0, negative 1, 4, 0. So we have this matrix. Remember, each thing in the first column represents x1. This represents x2. We kind of have the equal sign here, right? And this is whatever the constant is, whatever it's equal to. Now, with the Gauss-Jordan elimination, our goal, okay, is to get a matrix that has a 1, 0, 0, blah, 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 okay, and then something at the end, doesn't matter what, okay. Then we have a 0 underneath and a 1 in the next position, blah, 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 blah. And a 0, 0, 1. We want this first part of the matrix, if we exclude the constant terms, to be the identity matrix. Okay? It doesn't matter how we get there. Okay? But our goal is to have a 1 in the top left corner with zeros below it. Then having a 1 in the second row, second in the column, zeros below it. A 1 in the third row, third column, with zeros below it. Ideally, it would be nice to have those zeros above it, but that's not always possible. Okay? The piece that we're really, really looking at, okay, when we do this, is this bottom diagonal part. Okay? That's the crucial part. Okay? And that's our goal. Okay? If we can get zeros above it, ooh, that's awesome too. Okay? And we will be able to the vast majority of the time. Okay, so with that in mind, we can switch rows, we can add rows to rows, we can multiply rows, things like that. So first off, what I notice is that we have a 1 here. Okay, so I'm just going to go ahead and switch. Okay, row 1 and row 2. Okay. 0, 2, 3, 0. Okay. And now I want a positive one there, so I'm going to take and I'm going to multiply a negative 1 times row 1. 1, negative 4, 0. And so I've reached goal number 1. I've got a 1 in the top left corner. Now, what I want and what I want to focus on is right here, I need a 0. Well, how do I do that? Notice back up here, I took the second equation and I multiplied it by 2 and I added it to that thing. Okay? So I'm going to take the second row there, okay, and I am going to multiply it. Okay, I can switch colors here by, or I'm going to take the first row and multiply that by a negative 2. Okay, I'm going to add that to row 2. Now, I'm leaving row 1 alone. I'm not changing anything in that row. But to get the second row, I'm going to take that and I'm going to multiply it. So we're going to have, think of it this way. It's a 2x1 minus a 4x2 equals 0. The other equation would be 2x1 plus 3x2 equals 0. And I go, well, that was supposed to have been a negative a 1 there. And if I did it the way before, I would say, okay, well, let's multiply this by 2, and we would get 2x1, or if I multiply it by a negative 2, plus 4x2 equals 0. Then I would have this equation, and then I would add those two things together, right? We'd get 0x1, a 7x2 equals a 0. Okay. Okay. So if I take the first row and multiply it by negative 2, and that was a 7, not a 4, so that would be 11 there. Okay. 7, I mean an 8. That was supposed to have been an 8. I don't know where the 4. Okay. Now we say, aha, let's do that. That's going to give me a 0, okay, an 11, and a 0. 2 times 1, negative 2 times, negative 2 times 1 plus 2 is the 0. Negative 2 times the negative 4 is 8. 8 plus 3 gives me the 11. Negative 2 times 0 plus 0 gives me the 0 there. Okay. Now, I am going to, what I would like to have, okay, and this is where we can start playing around a little bit. What I want here is a 0, and eventually I want a 1 here. Okay, that's my goal. Okay. Now, I don't like working with fractions a whole lot when I'm doing these, so I'm going to be a little bit lazy. What I'm going to do now is I'm going to take row 2 and I'm going to multiply it by negative 4. And I'm going to add that to row 1. Okay. Or, I'm sorry, I started doing something. I am going to multiply that by 4 elevenths. All right. Yeah. And add that to row 1. Now I'm going to do my scratch work here off to the side a little bit just so you can see what we're doing. So we're taking 0 times the negative 4 elevenths plus 1. 4 elevenths times the entry in row 2 plus the entry in row 1. That's still going to give me a 1 there. Okay. This is why I want the 0 in that first column before I do anything with the second one. Notice my strategy was get a 1 in the top left corner, get zeros below it. Then I move to the second column and I start manipulating it. Then I'll go to the third if there's a third column to deal with and stuff like that. Okay? Because when I start manipulating stuff with the second column, it won't change that 1 that I already struggled to get in that top left corner. But then we're going to take 11 times a negative 4 elevenths. And I guess I should have done a positive 4 elevenths, shouldn't I? Okay, because I need a 0 there. Okay. plus the negative 4. Well, if I do that, we get 4 minus 4, which would be 0. And then the last row is 0 times the 4/11ths plus the 0, which is still 0. Okay. Get 0, 11, 0. So this time I left row 2 alone, and I manipulated that to get a 0 above that second column, second entry. Okay. Now I want to get this thing right here. I want that to be equal to 1. Well, how do I get that equal to 1? I take row 2 and I divide that by 11. 0, 0, 0, 1, 0. Now I've reached my goal. Okay. Notice this is the identity matrix, and that's what I said I was shooting for. Okay. I'm always hoping that'll happen. Okay. Because what that tells me is the top row gives me the equation that x1, I'll even write it out, plus 0x2 equals 0. So that tells me that x1 equals 0. The bottom row is 0x1 plus x2 equals 0, which just tells me that what? X2 equals 0. That's the same solution that we got the other way, right? Now, I could have started this and taken exactly the same steps, just multiplied the bottom row by 2, okay, added those together, and that would have given me a 0 for the x, okay? And this is where the Gaussian elimination it would look like. So if I did the Gaussian elimination, let me try to, would you move, you stupid thing? I might tackle a little different because we have 2x1 plus 3x2 equals 0, negative x1 plus, what was it, 4x2 has to equal 0. That looks like a greater than sign, doesn't it? So with a Gaussian elimination, what I might do is do exactly the same thing I did in the last one. Say, okay, well, we've got this matrix, 2, 3, 0, negative 1, 4, 0. And I would take that and I would multiply by row 2 by negative 2, or I multiplied it by 2 before. We'll do it exactly the same way. Okay, so 2 times row 2, and we're going to take row 1 and we're going to add that to it. Okay, so 2, 3, 0. So if we do that, we're going to get 0. Okay, 2 times row 2 plus row 1 would be 11. Okay, 2 times the row 2, okay, plus that be 0 again. Okay, let's see. 2, oh, wait a minute. 2 times, yes. Did I do have a typo up here? No, okay. But notice, for some reason I was thinking we have a 0 and 11 equals 0 there. This Gaussian elimination should give you one of your equations looks like that. So we know that 11x2 equals 0. So that tells me x2 has to equal 0. Then we go back and substitute in and say, oh, well, if that's equal 0, then 2 times x1 plus 3 times 0 is 0, right? Mm-hmm. From the top equation, so that means 2x1 equals 0 and x1 equals 0. Okay? So Gaussian elimination, the goal really is to get a row similar to this, where you have one of the variables, all the other variables are 0, and then whatever the constant is, okay? And that will solve it for one of the variables. And then you go back and substitute in, because you should have a row then with that one and another variable, like this row, okay? I could go back and go, oh, I know what x2 is, so I could go ahead and evaluate that equation to find out what the other variable is. It's just the back substitution. It's the matrix way of writing exactly what we did up here. Okay? The Gauss-Jordan elimination, what we do is we take care of all of the need for back substitution, by getting all of our equations to be equals, x1 equals something, x2 equals something. Okay? So let me do one that's a little bit tougher, involving more steps and more variables here. Okay? So let's say we got, let me, I got an example here. Try to pick one that you don't have in the textbook type stuff already. So let's say we have x1 plus x2 plus x3 plus x4 equals 13. Okay? And 2x1 plus 3x2 minus x4 equals -1. Negative 3x1 plus 4x2 plus x1 plus 2, that's x3, sorry, plus 2x4 equals 10. And x1 plus 2x2 minus x3 plus x4 equals 1. All right, I want to solve that system of equations. So the first thing is set up my matrix. We got 1, 1, 1, 1, 13, 2, 3, -1. Whoop. Be careful if they're missing zeros. That has a 0. Then -1, -1. Okay. -3, 4, 1, 2, 10. 1, 2, -1, 1, 1. So there's my matrix. Okay. Actually, it's really nice. I've got the 1 in the top left position already. So cool. Now I want to work on getting zeros below that. Okay. Now, just to save some space, I'm probably going to take several steps at once. Okay. You might want to write down a matrix for each of these or something, but I'm going to leave the first row alone. Now, to get my new second row, and I'll color code these for you, okay, I'm going to take a -2 times row 1 and add that to row 2. And I do that because looking at the first position here and the one right below it, in order to get a 0, I can take 1 times -2 plus 2 is going to give me 0. Okay, I want their coefficients to be the same. Okay, so that's going to give me a 0. -2 times 1 plus 3 would be 1. -2 times 1 plus 0 would be -2. -2 times 1 plus a -1 would be -3. And then -2 times 13 is -26, -27 when I add those. Okay. Now for the next one. For row 3, I want another 0 there. That's my goal. I want zeros all below there. So now I'm going to take 3 times row 1 and add that to row 3. So 3 times 1 plus -3 is 0. 3 times 1 plus 4 is 7. 3 times 1 plus 1 is 4. 3 times 1 plus 2 is 5. 3 times 13 is 39, plus 10 would be 49. And now I want to get a 0 in the last row. So for the last row, I'm just going to take that row and subtract row 1 from it. 1 minus 1 is 0. 2 minus 1 is 1. -1 minus 1 is -2. 1 minus 1 is 0 again, and 1 minus that would be -12. Right, now, I have all of those zeros where I want them. I got a 1 in the top left and the zeros all below it. Okay. Now my goal, and honestly how I work these is I look at this one, and the first thing I do is try to get zeros in everything above and below it. Okay. If there's a 1 there, great. If not, I usually save that until the very, very end. Okay, because then I might have to deal with fractions and stuff, and sometimes I don't want to do that. All right, so to get a 0 above that, I can take row 1 and subtract row 2. So I'm going to take row 1 and I'm going to subtract row 2. So you'll notice now, here's the advantage of getting all those zeros in column 1 first. I'm always going to be multiplying by 0 and adding 0. So it will not change my first uh, top left entry there. But row 1 minus row 2. So 1 minus 0 is still 1. 1 minus 1 is 0. 1 minus negative 2 would be 3. 1 minus negative 3 would be 4. 13 minus negative 27, so that would be 40. Okay. Now I need the 0 below it, and I'm leaving row 2 alone. Okay, so for row 3, I want a 0 where that 7 is. Okay, so this is the one I'm currently working on. I want that to be a 0. So I got the top one already. Now I'm working on that one. So in order to get a 0 there, I'm going to take a negative 7 times row 2. I'm going to add that to row 3. So we get a 0 there. Okay, and a 0 there because we get negative 7 times 1 plus 7. Negative 7 times negative 2 plus 4. So that's what? 14 plus 4 is 18. Okay. And I'm doing all the arithmetic. I want you to be careful because I'm doing the arithmetic in my head, and it is definitely very possible that I'm going to make a mistake along the way. Okay, so keep on the lookout for that and double check my work. Okay, let's see. Now we're into the next one. So a negative 3 times negative 7 plus 5, so that would be 21 plus 5 would be 26. Okay, and negative 27 times negative 7 plus 49. So that's 49. Carry the 489 plus 49. 18, 13, so 238. And last, I need to get this one here to be a 0. Okay, and I colored over top of that with, so this one right here, I need to have to get that to be a 0. So what do? I'm going to take, and remember, I'm always dealing with row 2 here, just because I have a nice 1 there, and that's what I'm focused on. Okay, so some combination of row 2 plus the row 4. Oh, well, I can just take row 4 and subtract row 2 from it. Okay, 0 minus 0. 1 minus 1 is 0. Negative 2 minus negative 2 is 0. Okay. 0 minus negative 3 would be a positive 3. And then let me make some room for my scratch work. What do we have? Negative 12 plus 27, right? So that's 15. Okay. So notice I'm making some headway, and I have the one here with zeros below it. I have the one here with zeros above and below it. So now next I'm going to focus on this row. Now that's a lot of big numbers, okay? Um, so what I'm going to look at is what's the greatest common divisor for these things, and I think it's a 2, okay? So we're just going to divide everything in that row by 2. And I'm going to write that down separately here. So I'm just going to take row 3 and divide that by 2. And you know what? I'm going to look at row 4. I'm going to go ahead and divide that by 3, because that'll give me another 1 in a good spot. So you can always divide a row by anything that you want along the way, anytime. Okay? But now my focus, okay, is on this entry. Okay? Eventually I want a 1 there, but I do want zeros above it and zeros below it. Okay? And this one's going to take a different combination of some of those things. So looking at that top row. Okay? So right now, I'm going to leave the third row alone. And since there's already a 0 below it, I'm going to leave row 4 alone as well. So for the top row, I know if I took 3 times row 1 and subtracted row 3 from it. I wrote down plus, but I need a minus. Okay? That's going to give me a 0 in this top position here, because we're going to wind up with a 9 minus a 9. Okay? All right, so and am I writing that the way I want? All right, so let me just go ahead and write down and work with exactly what I have. Okay, I kind of wrote it down a little bit funny, and maybe not exactly what I should probably do. Okay, um, but I gotta be careful with like my signs and stuff like that, and because that's where I typically make mistakes. Okay, but if I took 3 times row 1 and subtracted row 3, that would leave me with a 3 in this position. Okay, and if I did 3 times row 1 minus row 3 here, that would be a 0. 3 times row 1 minus row 3 would be a 0 there. Let's see, 12 minus 13 would be negative 1. And 3 times row 1, that would be 120 minus 119. And that would be a 1 there. Okay. So notice I got a 3 up in that top left position. That's all right. Okay. I will deal with it at the end. Okay. I'll eventually just divide that row by 3 if I need to. Okay. Now for row 2. In order to get row 2, I need to multiply row 2 by 9. And then I'm going to add to that 2 times row 3. So 2 times 0 plus 2 times 0 is 0. Or 9 times 0 plus 2 times 0. Okay. 9 times 1 plus 2 times 0 is 9. 9 times negative 2 is negative 18. Plus 2 times 9 is 18 would be 0. Okay. Then we'll have 9 times negative 3 plus 2 times 13. So that's negative 27 plus 26. That'd be negative 1. Okay. And then the last row there, what about 9 times 27? Okay. And plus 2 times 119. Negative 243 plus 238. 5, maybe negative 5. Yeah. So notice I messed up my 9, or I messed up my 1. That's all right. Okay. Goal number 1 for me is always getting the zeros in the right places. Okay. So now I've got zeros above it and zeros below it. Zeros above that, zeros below, all those zeros below. Okay. Now the last thing is I would like to get zeros in these 3 spots. Okay. So I'm going to take those, I'm going to add multiples of this entry right here. That's usually what I should do. See, I did not do that last time. did I? I didn't add a multiple of the other row. I started multiplying row 1 instead, because that's just what my eye tracked to, and I thought it would be easier to do in my head. Okay? So I'm going to take just row 1 and I'm going to add row 3 to that. Okay? That's going to be 3, 0, 0, 0, 6. Okay? Now I'm going to take row 2 and I'm going to add row 3 to that one. It's going to be 0, 9, 0, 0, 0, 5 plus negative 5. And then I am going to take row 3. Oh, I should be putting row 4s there. I am so sorry. I used the wrong subscript. And then I'm going to take row 3 and I'm going to add 13 of the row 4s. So that's going to be 0, 0, 9, and let's subtract. So that way I get a 0 there. 13 minus 13. And so we're going to have 119 minus 13 times 15. All right. So 13 times 15. I'm going to cheat and use my calculator now. Come up with a negative 76. And then row 3, I'm just leaving alone. So I need to extend my little bracket there. I'm going to have 0, 0, 0, 1, 5. Hey. So I got all zeros everywhere that I want. Okay. And I'm, considering looking at, this diagonal here. I want zeros above and below it. Now I want to get ones in all those spots. Okay. And of course, I did not leave myself a whole lot of room. So next page, I guess. If I divide the top row by 3, and I'm going to have to scroll back and forth here. Okay, I'm going to take 1/3 times row 1. That would give me 1, 0, 0, 0, 2. Divide by 9 on that second row. Okay, so 1/9 for row 2. That was 0, 1. That was all zeros. Let's see. Divide the next one by 9. That'll be 76 over 9. So 0, 0. I forgot to sign negative. 0 and negative 76 over 9. Let's see. Yeah, and then the last one was already a 1. Okay, so that's 0, 0, 0, 1, 5. That tells me my solution. X1 has to be 2, X2 has to be 3, X3, 0. X3 is negative 76 over 9, and X4 is 5. Now, if you do the Gaussian elimination, you would actually stop back here. Okay? Because you would already have now found that X4 was equal to 0. And then you could use the row above it and say, oh, well, 9x3 plus 13 times 0 has to equal 119. So x3 has to equal 119 over 9. I clearly have a mistake somewhere in here. If we do that, oh no, x4 was equal to 5. Let me fix that since I'm talking about it. Okay, that bottom row tells me x4 equals 5. Okay, so then 9 times x3 plus 13 times 5 equals 119. Minus 13 times 5, 13. But I'm getting 9x3 equals -54. Okay, so I do have a mistake somewhere in here. Okay, and it would have to have happened after that because I'm coming up with 54 over 9, and down here it was 76. So I did some math wrong here in my head. Okay, on that last step. Um, 13 times row 4. That was 0. Let's see. Let me write my scratch work down so I can fix this. Okay. Row 3, 119 minus 13 times 5. Yeah, that should have been 54. Okay. Which then would match what I have written down up here, because that wasn't a negative, that's a straight U mark there. That would be 54. So then x3 is 54 over 9, which is what we would have gotten down here if I had been more careful about what I was writing down. Hopefully you all caught that along the way. And then, of course, once you know x4 and x3, you go back up to the next row, solve that for x2, and then back solve for the x1. That's the Gaussian. The Gauss-Jordan elimination is where you wind up with this. Okay? It does not matter how you manipulate these rows. Okay? There's just a few rules to follow. Okay? You can multiply row by anything. Okay. Okay. The second thing is you can add, subtract. You can multiply by a constant, of course. Okay. You can add or subtract two rows. Okay. And lo and behold, that's really only the two rules that you have. Okay. And you combine those together. So notice I was up here on this one. I multiplied both rows by something and then I added them. And that gave me my new row. Okay. And you can do that in any order you want. My advice is once you get, okay, let me change here, non-zero numbers here, get zeros below it. Then move on with get zeros above and below whatever's in the second row, second position. Then move to the third row, third position. Get zeros above it and below it. Move to the next one. Always go down that diagonal, okay, until you get to the last row. Get zeros above and below. And then once you do that, then go back and try to get, like we have here, then divide each row by whatever that number is in order to get all ones going down through here, okay? Because that's the eventual goal. All ones there, zeros above it, zeros below it. Okay, I hope this helps. And if you need some more help with it, or if something was unclear, or heck, as I said, I may have made another mistake somewhere with the arithmetic. Um, uh, so, please let me know, or, whatever. Okay.